Okay guys, I want to show a very basic example of using the gyroscope to go straight forward. And what we're going to say is whenever it's driving along the table, the motor speed is 30. And when we have to correct the heading, if it starts to drift off to the right or off to the left, we're going to put 2 more to one motor and 2 less to the other motor. So of course when we're using the gyroscope, first thing we have to do is reset it so it sets back to 0. And then we'll just put power to each motor. So we'll put, we said 30 was going to be our normal speed, so we'll put 30 to the left, Control C, Control V, and we'll put 30 to the right. And then we have to make a decision. So we'll go to Flow Control, get what's called a switch, and we say, is the gyroscope, is the reading from the gyroscope equal 0? Because if it does equal 0, that means the robot is still going perfectly straight forward. So we come up here and we don't do anything. But if the reading is not 0, then we come down here because we need to correct the heading. So either put a little bit more power to the right wheel, and that will make it turn to the left a little bit, or we have to put a little bit more power to the left wheel, and that will make it turn to the right a little bit. So okay, so it does not equal 0. So the first thing we have to do when we come down here is we have to ask another question. We have to say, is it greater than 0? So we'll grab another switch, drop it in there, and so we say, is the gyroscope greater than 0? And if it is, that means the robot has veered off to the right a little bit because the gyroscope has rotated to the right a little bit. So if that's true, then we'll put a little bit less power to the left motor. And so we said our error correction was 2, and we normally are going 30, so we'll put 28 to the left motor, Control C, Control V, and we'll put the error correction, so we'll put 2 plus 30 to the right motor. And that will help push the robot back towards the center a little bit. And then if it's not, so this says, is the gyro greater than 0? If it's not, then it comes down here. And we would basically do the same thing, except for we would be putting, if it's less than 0, that means the robot is veered off to the left a little bit. So we need to put more power to the left motor, less power to the right, and that will steer us back towards the center. So let me zoom out here. So I just wanted to show you that real quick. Basically, we reset the gyroscope, we put the same power to both motors, and then we ask ourselves, does the gyroscope still 0? If it is, then we don't do anything because that means the robot's still going perfectly straight forward. If it's not equal to 0, then we come down here and we say, well, is it greater than 0? Which would mean the robot had veered off to the right a little bit. And if it is, then we put a little bit more power to the right motor, less to the left, and that will bring us back to 0. And then I didn't put it down in here, but we would do the opposite down here. So we'd put a little bit more to the left motor and less to the right, and that would bring us back to the right a little bit. But one thing is, no matter which path you do, when we come out here, we're at the end of our program. So what we really need to do is put all of this inside of a loop, because we need to keep asking this question, does it equal 0? If it does, don't do anything. Go back to it again. Does it equal 0? Does it equal 0? But if it doesn't, then we come down here, we do a little bit of a correction, but then we need to come back and ask, is it 0? If it is, don't do anything. If it's not, come back here, do another correction. So we'll put all of this inside of the loop, if we can. Oh, maybe it's, yeah. Oops. There. Okay. So I just wanted to show you that real quick. This is a real basic example, but in the description below I'll put some other things that I would typically do when using the gyroscope, like the error correction and whatnot. But I just wanted to show this real quick. Thanks. Bye.